Well, thank you for joining me. This segment, I'd like to look at a question that requires graphs of derivatives and f dash. So the graph, the derived function. So we've been given the graph of f dash. So this is shown, f dash is shown. So really, this axis is the derivative, not the actual function. And you can see that they want to know the function, the actual function that this is illustrating is decreasing for which values of x. Now let's just analyze what this means. Here it means that the derivative is 0 at x equals 1. Now, if the derivative is 0 at x equals 1, the derivative is 0, means that's a stationary point. So there's a stationary point at x equals -1. On the function, there is a stationary point at x equals -1. So it's turning, it's either a minimum or a maximum. Now, before -1, you can see here, before -1, the gradients are negative. So you've got negative gradients. Now, what do we know about a negative gradient? The derivative is negative, which means it's a downslope. Right? So downslopes have negative gradients. So downslopes before x equals -1, there's a downslope. So it's coming down. Because it's a straight line, when the derivative is linear, the function is quadratic. I'll just put that here. The derivative is linear, and the function is a quadratic, and it works in reciprocal. The derivative of quadratic is linear. So we're going to have a minimum, and it's going to be turning at that point here. And then notice positive values. Positive values, it's above the x-axis after -1. So here that means the derivatives are positive after x equals 1. Positive derivatives means upslopes. Upslope is a positive derivative, means the functions are increasing. Here the function, if the derivative is negative, it means therefore the function is decreasing. Decreasing means coming down. If the derivative is positive, that means an upslope. It means that the function is increasing. And we want to know, so then it's going to, after that value, it's going to increase. We want to know where is the function decreasing, and it's decreasing before -1. So it's decreasing to this point here because the gradients are negative. So anything less than -1, the function is decreasing because the gradient, you can see this line here, is negative. Because this line is negative, they're all negative values underneath the x-axis. That means the derivative is negative, the function is decreasing. So we want from -infinity up to 1, but not including 1. You cannot have including 1 because it's actually decreasing before. At that point, it's no longer decreasing. So I would select E because it's decreasing before that point. Because once it reaches that point, it's no longer decreasing. It's actually instantaneously 0 and 0 decreasing up to that point. When it stops decreasing, it's a difficult question. Right, until I talk to you again, that -1 is the final condition. It's actually including that value. It's decreasing up to that value. At that value, it is instantaneously it's not really decreasing at that value. It's instantaneously stationary at that point. So we can't include it. So it's not decreasing at -1. Right. Stay happy.